Hello, welcome to my talk on Multicloud with Tanzu today. I hope you're still able to absorb some information at that time of the day, because it's quite some stuff we're going to cover. What we're going to do within the next 50 minutes is we're going to talk a bit about multi-cloud, the reasons why we go and follow a multi-cloud strategy, and also what challenges we face on that path. Okay, we're then going to have a look at what the Tanzu portfolio can offer us to help manage the complexity we are adding by following a multi-cloud strategy. And then most of the time, actually, we're going to be looking at a demonstration of a cloud burst scenario, but I'm going to explain more about that later. So let's start by looking at some whiteboard slides that I prepared for you to talk about multi-cloud. So when I talk about multi-cloud, what I have in mind is a user surrounded by applications that are placed in different locations, right? So we could have some apps on AWS, some on GCP, and we could have some of them in local data centers. And the way we distribute these apps onto the various platforms we have available might depend on lots of things. So there are lots of reasons why we're following a strategy like that. And I try to list some of those. So it could be about availability, right? We could say, we don't trust just our local data center to provide the availability. We think that AWS or Google are much better prepared to provide such a high level of availability, what we're expecting. So we might be running multiple instances of the same application in different cloud platforms, and then allow the user or allow some mechanism to fail the user over to a different place in case something's wrong with one of the regions or one of the cloud providers or our local data center or whatever. It could be about latency. We might want some services to be very close to, for example, the origin of the data it is processing. That could be a use case. So latency might be one of the things we're looking at. It could be bandwidth. Those two might be quite related. So when I'm closer to something, there's a higher chance I have a good bandwidth between the 2 points, right? I might be afraid of a lock-in, right? The more applications I throw onto one public cloud provider, the more dependent I become on that cloud provider, because I'm using their APIs, I'm using their technologies, everything I built around that is made for that one public cloud provider or private cloud provider, right? It could be that as well. So you might be afraid of getting locked in by VMware, and that's why you're spreading your applications to the public cloud. Maybe that's what you're thinking. And finally, last but not least, these public cloud providers, they certainly have some amazing features and services out there, right? Just stuff you can just consume like that, no problem at all. It's all managed for you, and that's a big value for your business and to speed up your development processes and a lot more things. So lots of reasons actually make us follow a multi-cloud strategy in the future, and we're expecting that to become more and more a thing, and that's why, we're preparing for that, right? So, but for everything that's good, there is something bad about it, right? So nothing's free. So let's look at some of the challenges. If you're using, as in this example, 4 different cloud providers, you are going to use 4 different APIs, okay? And that means you're going to be using 4 different types of tools, 4 different tools to manage all of that. So you're going to be deploying to AWS, you're going to be deploying differently than to GCP. And then there's GCP just has their way of managing things. They have their cloud console. AWS has theirs. Azure has another one. Then cross-cutting concerns like billing, chargeback, these types of things. Everyone has their own tools, and it doesn't really come together in one, right? So there's some tool sprawl that we're facing, right? More and more tools. People need to learn more and more things. The more clouds I provide, the more cloud platforms I provide access to, the more tools people will need to learn and adopt into their building and deployment process to make use of that. Okay. When we get an environment, when our application landscape gets spread across so many platforms, and maybe we're using Kubernetes and we're getting hundreds of Kubernetes clusters after a while because, say, every team is running their own handful of Kubernetes clusters, then something we call policy enforcement is going to come up very quickly, as in managing the right people have access to the right things, for example, Kubernetes clusters, managing where people get container images from, so we don't just randomly pull in stuff from Docker Hub and adopt malware into our development and rollout process. So there's lots of things we want to manage across this entire environment, and the more spread out it becomes, the more different platforms we adopt, the more places we have to deploy to, the more complex this is going to become. So service consistency is another aspect. When, let's say I am the developer or the DevOps engineer who is consuming that platform because I want to run my application on it. If I go to GCP or AWS, I'm going to get, let's stick to the example of Kubernetes. I'm going to get Kubernetes clusters, but I will quickly find out that different Kubernetes clusters work a bit differently. They're all CNCF compatible, no problem, but the devil's in the details, right? So let's say ingress controllers on that platform work a bit differently than ingress controllers on the other platform. And managing that complexity requires me to pre-select the platforms I want to run on, make the changes to my code because the rollout process, the deployment will be a bit different. And yeah, it's just, and when I want to move to a different platform, I have to rethink all of that, right? I have to adopt to the new way of doing things. So there's work involved, there's a portation effort involved if I want to move my stuff to a different place. And it's just not the same service that I'm getting at any given location. I mentioned connectivity as another challenge because running one app in one region is fine, but if we're doing this for example, availability reasons, or maybe we're doing this for resource extension reasons because we want to burst into the cloud, we suddenly have one app, let's say, comprised of multiple microservices spread across multiple cloud platforms, and they still need to talk to each other somehow, right? So one microservice talking to another, right? A very basic case. And if one microservice runs on AWS, the other on GCP, or maybe just another region, and therefore another Kubernetes cluster of AWS, then we need to think about how we connect the services together. And that's a challenge. And if we extend that into the local data center and have applications speaking to one another across the WAN connection of your company, then things get more complex because you need to manage that traffic flow somehow. So much for the overview, right? We identified lots of reasons to go into a multi-cloud. We identified lots of challenges as well. And in the next step, I want to show you what Tanzu offers in that respect, what the Tanzu stack offers to face and manage and mitigate these challenges that we've just identified. So first off, let's start at the bottom. In Tanzu, we have a Kubernetes distribution, which we call Tanzu Kubernetes Grid. And that distribution of Kubernetes has two big themes, if you will. One is it's tightly integrated with Vsphere if you want it to. So we have that full integration in the Vsphere client. It's super easy to use and manage for any existing Vsphere admin out there. And the second is Multicloud. And you can see in that picture that we have a bunch of different platforms available today. And that list of platforms is being expanded every couple of months, right? So we're constantly working on providing new platforms for Tanzu Kubernetes Grid. Down here we see Vsphere because that's our product. We make sure our products work together, right? And currently we have access to AWS and Azure. So we can deploy Tanzu Kubernetes Grid clusters on AWS and on Azure. So with Tanzu Kubernetes Grid, we will be able to deploy TKG clusters on every of these supported platforms. And that means no matter where we deploy to, we will always get the same result, which is a TKG cluster. And our users will be able to just consume them with the regular Kubernetes API. Okay, so there's nothing special about it. It's all CNCF conformant. There's no problem there at all. Let's skip ahead. So on top of that, being able to roll out Kubernetes is a good step, but there's lots more, right? So for example, we have a product called Tanzu Mission Control, TMC in short. And that really has two aspects to it. The first being the lifecycle management. So we have that user up here, maybe that's a DevOps engineer, and it connects to Tanzu Mission Control via API, command line interface, or the web front end we're providing. And Tanzu Mission Control will talk to connected instances of Tanzu Kubernetes Grid, and via that connection, that user will be able to create new clusters on all the connected environments. So we could have 3, 4, 5 Tanzu Kubernetes Grid environments connected to Tanzu Mission Control, and the user would be able to select where the next Kubernetes cluster is supposed to be deployed. And also the user could scale the cluster from there, could upgrade the cluster to a new version, could delete the cluster as well, right? So it's a full self-service that is made for multi-cloud. The second aspect to Tanzu Mission Control is the policy management aspect. So it's not just a tool for the DevOps engineers or the consumers of the platform, let's put it that way, whoever that might be. But it's also a tool for the administrators of the platform, the people that are responsible for the entire environment and its security and compliance and all these things. So all the clusters that we create via that self-service or external clusters, that could be anything, that could be, for example, GKE cluster or the AWS native Kubernetes. We could attach those to Tanzu Mission Control as well. And as soon as a cluster is attached to Tanzu Mission Control, we are able to enforce policies on those clusters globally, or we could just specifically pick certain cluster groups or individual clusters to make sure certain things are met. And that's a big step, right? So we're now able to deploy Kubernetes clusters everywhere, wherever the platform administrator allows us to. And on the other hand, the platform administrator is able to make sure that certain things are kept in check. Okay, up next there is Tanzu Service Mesh, or TSM in short. And that is a very, very great tool, and the focus of this talk actually, and also the demo we're gonna be seeing later on. It does many things for us, but two things I want to highlight now. Everything we do with Tanzu Service Mesh, requires us to have a service mesh in each Kubernetes cluster. And we're using Istio for that. And when you onboard your Kubernetes cluster into Tanzu Service Mesh, TSM will automatically install and lifecycle manage Istio for you. Okay, so the installation of Service Mesh in each Kubernetes cluster is handled by Tanzu Service Mesh for you. And also stuff like certificates and keeping it up to date and all these things, it's all managed, right? So you have the full advantage of that just a basic service mesh gives you just by attaching your cluster to TSM. So in addition to that, and that's what we're going to be using in today's demo, in addition to that, but not only, so there are more features to TSM and things you can do with it, but what I want to focus on today is called the global namespace. And I'm going to talk about that in just a few minutes. So taking a step back, we're seeing this picture in the bottom left corner, which we've just talked about quite much. And if we think back about the challenges that we have identified in the very beginning, tool sprawl, policy enforcement, service consistency, connectivity. So these things are all very nicely covered. And I try to highlight the different parts of the Tanzu portfolio in the right color so that you can map them to the challenges they're solving. Right, let's go straight into the demo, but we need to talk a bit about what we're going to do because it's complex and I want everybody to be able to follow. So what we're going to set up is, let's say we have a private cloud environment on the left-hand side over here, and we have access to a public cloud environment, and in this case I'm going to be using AWS. And of course, in the private cloud environment, we have Vsphere running. Both environments, both cloud platforms we have access to run Tanzu Kubernetes Grid, okay? On top of that, we are going to deploy a Kubernetes cluster, which I just called workload clusters in this, okay? So in Tanzu Kubernetes Grid, we make a distinction between management clusters and workload clusters, but that's nothing to worry about now. Just so we've heard the term workload cluster is, as the name suggests, a cluster that is supposed to run application workloads. So what we're going to do is we're going to create a namespace on that workload cluster so we're able to deploy an application, and that application is going to be a microservices-based shop application. That namespace will have a name, or let's say a local domain, just so we can talk about it more easily. And we're going to do the same on the workload cluster, that runs on AWS. The same namespace, they could be named differently, it doesn't really matter. The point here is we're going to connect both our workload clusters to Tanzu Service Mesh, and we're going to create a global namespace. And this is the right point in time to talk about GNS, the global namespace. What it allows us to do, basically, at least technically it's not quite correct, but I like to think about it that way. It allows us to basically punch a hole into both namespaces or multiple namespaces and use that hole to carry traffic or transport traffic from one namespace into another. Okay. Another way to think about it is to create one big namespace that spans multiple Kubernetes clusters. That could be another way to explain the global namespace. So what that allows us to do is, and that is our scenario we're talking about here. And let me zoom in a bit so it becomes clearer which part of the slide I'm talking about. We're going to deploy a shop application that consists of multiple microservices. There's a shopping microservice, which is the point of contact for the user using the shop application. There is a catalog service, which has its own database. And there are multiple other services, like what else could a shop be using? There could be a user service for authentication. There could be an order service to place orders, all these things that a shop is usually comprised of. And in our situation, let's say the local data center is at very high utilization and the administrators of the underlying platform are telling us, now, sorry, we're running at capacity here, so 100% utilization. There's nothing we can do to give you any more resources at this point. But we also know that let's say the marketing department is running a campaign next week or in 2 weeks, and that is going to increase the utilization on the catalog service a lot. Let's say by, I'm just making the numbers up, let's say they're going to triple, okay? And of course, all the other services, we don't just expect people to browse the catalog, but hopefully some will also place orders. So the other services are going to rise in their capacity requirements as well. So if we didn't have that global namespace that connected us to a different Kubernetes cluster that's running on AWS, that would be quite hard, right? But in this way, we can very easily just deploy the catalog service to the Kubernetes cluster that's running on AWS, like that. And the shopping service will use this hole we punched into the namespaces, the global namespace, the connection that was created between the two namespaces by doing so. It can use that connectivity to still connect to the catalog service, even though it's running on a different cluster in a different location, in a different city, maybe on a different continent, right? And so that will move, say, 20% of the capacity to AWS. On AWS, we can reach we can scale up as far as our money allows, right? And that will give some headroom in the local data center because those 20% that we just talked about, the catalog service is away, and that those resources become free in that Kubernetes cluster. So let's say the utilization drops to 80% for our environment, and that gives some headroom for the other services to scale up as well. Okay, so by moving that big service that's gonna rocket in the next weeks, we created some headroom, and we're very flexible about scaling that catalog service when the resource consumption actually rises. Good, let's jump into the demo. What we're looking at here is Tanzu Mission Control. And I was given, so I'm putting myself into the position of the DevOps engineer responsible for rolling out the application and running that cloud burst that we've been talking about, right? So I've been given access to this Tanzu Mission Control interface, and someone created a cluster group for me. So that's sort of my space in which I can create my clusters and manage my clusters, right? That notion of a cluster group in Tanzu Mission Control is then used later on to apply policies at the group level, or maybe even higher at an organization level. But for what we want to show, this doesn't really matter. So I just go into the shop cluster group, and let's see what we have here. So it gives me a panel up here that allows me to create a new cluster or attach an existing cluster. And that's what I mentioned earlier. like when you already have existing clusters such as OpenShift or Rancher or GKE or AWS native clusters. So you could attach all of these to Tanzu Mission Control, and then use the policy and access management and all that stuff, the entire management part of Tanzu Mission Control to manage those clusters as well. So further down, we're seeing that we already have an existing cluster here, which I called on-prem shop. So that's the name of the cluster. It's in a healthy state. It's ready to receive workloads. And the provider on which it runs is Vsphere. The version of Kubernetes is 1.22, so that's quite recent. Further to the right, we see some information about resource utilization, but that space is currently occupied by my picture-in-picture here, so we're not seeing that. But we could go into that cluster and have a closer look here. So, as I said, some resource utilization numbers, some more information about that cluster and its available resources, some health management to see the most important agents are available, and 3 worker nodes, and we see something about the integrations. And in this case, we have an integration which is called Tanzu Service Mesh. So I have a Tanzu Service Mesh account, and I was given access to that. And I added that integration to my cluster. And that's when the cluster was onboarded into Tanzu Service Mesh, and Istio was installed, and all the prerequisites were installed to run that global namespace cloudburst scenario that we're going to run later on. So going back to the shop cluster group, to do what we want to do, we still need an additional cluster which runs in a public cloud. And that's why I'm going to run you through the process of creating that cluster very quickly. So we do that just by hitting create cluster. And then we're presented with the option to select between multiple management clusters. So I earlier said that in TKG, in Tanzu Kubernetes Grid, we have management clusters and workload clusters. And management clusters manage workload clusters. So every management cluster basically represents an environment into which we can deploy workload clusters. So every management cluster basically represents an environment into which we can then deploy workload clusters. Currently, I have access to 2 management clusters. One management cluster is called on-prem hosted, and that's the Vsphere provider that we were talking about earlier when we looked at the existing Kubernetes cluster that's running on that Vsphere environment. And now I want to create a cluster on AWS, so I use the AWS hosted management cluster and press continue. So I'm not going too much into the detailed concepts here of provisioners and stuff, but basically you need to know that you need to have AWS credentials and selected and pre-configured in Tanzu Mission Control. That's what we're selecting here. We give that cluster a name. We call that the remote shop. The other one is called the on-prem shop, so that works. We select the cluster group that's already selected because we kicked off the workflow from within that cluster group, and the rest is optional. So we hit next. Since we're on AWS, we have some options here available in terms of the region to deploy to, and you need to make some preparations in that region as well, such as uploading an SSH key, which will be installed into the master and worker nodes. So I know that in my region, EU West 1, those preparations have been done, and I'm already given that key that I have uploaded. I can select a Kubernetes version, and we're seeing that the Vsphere environment is actually a bit more up to date than the AWS environment here. And that could be because the AWS one is just missing the most recent patch or something, which is why we're not seeing the 120 version. So we're deploying 119, but that also gives us the chance to demonstrate that different versions of Kubernetes can easily work together and be managed in parallel at the same time without any problems. The rest is very network specific. There's no reason to make any changes to that here, so I just hit next. And in the third step, it's about the master cluster, the Kubernetes master cluster. And since I am a resource-aware person, right, I am just gonna deploy a single node master here. But since I know that we're gonna need some more resources to run all that Tanzu Service Mesh stuff on top of it, I am selecting a bit larger instance type here, and the minimum that I should be working with here is M5 X large. Right, so that master goes into the availability zone EU West 1A, that's good. And finally, we set up node pools. The node pools need to use a larger instance type as well. So I'm scrolling down to select M5 X large here as well. M5 X large, where is it? I've probably just scrolled past it already. Here it is. And I could make this more complex by choosing multiple node pools in different availability zones, but I want to just save us the time. So I'm just going to increase the number of worker nodes in that availability zone and just hit create cluster. So this unfortunately is a bug in the UI we're currently seeing sometimes. It has actually worked. It's just the UI that is showing this error message here. If we jump back into the cluster shop, into the shop cluster group, we can see that the remote shop cluster is actually in the list and it's in the process of being created. And well, that's just something we have to wait for now. It might take a while. Okay, with that set up, the cluster has been deployed successfully. We can see it here. It's in a healthy state. It's on AWS. It's 119.8 as the version. And let's click quickly into it to see a bit about the details. So we can see that there's still one agent in the process of being deployed. Actually, there's an update in progress. Okay, fine. But that doesn't stop us to continue. So what the next step would be to connect Tanzu Service, to connect the cluster to Tanzu Service Mesh, okay? We do that by looking at the integrations panel. We click Add Integration, select Tanzu Service Mesh, and we want that to be enabled for all the namespaces by default. Cool. And we can see the integration is in the list now, but it's not in a healthy state yet, neither the adapter nor the integration workloads. So we wait for that to finish and be healthy. So the integration has successfully installed. We can see down here, we have 2 green checkboxes for the TMC adapter and the integration workload for Tanzu Service Mesh. And so we should now have 2 Kubernetes clusters connected to Tanzu Service Mesh. And we can just go ahead and prove that by opening the TSM web interface. And the best place to look at would probably be the cluster overview. We can see here we have 2 clusters available. The remote shop one is new, the on-prem shop is old. That already existed before. So that all has worked. We now have Istio installed and we're connected to TSM. The next step would be to connect to our Kubernetes clusters, and the preparations we need to do is to create the shop namespace so that we can later on connect that namespace to the other namespace in the other cluster by creating that global namespace I was talking about earlier. To gain access to our Kubernetes clusters, we click Action, click Access this cluster, and we download a kubeconfig file, which we can then use in the with the kubectl CLI to authenticate to our cluster and to run commands against it. And I'm doing the same for the on-prem shop cluster now, just so we have access to both. Okay, that is it. And we can now switch over to a terminal window to actually connect and do the preparations we need to do. So as the description in TMC explained, what we need to do is we need to tell kubectl to use that file we downloaded, and we do that by exporting the kubeconfig variable. And now we could just do kubectl get nodes, and that should show us all the nodes that comprise that cluster, and that includes one master and 3 workers. And we're going to do the same on the AWS cluster by exporting the same variable, but just pointing to the other kubeconfig file. And we may now run the same command, and we see the output is different. We can see we have 120 version on Vsphere. We have 119 as the version on AWS. The naming scheme for the hosts is a bit different, but in the end, both are TKG clusters, and we are now ready to use them. So the next step would be to create the namespaces in those clusters. We do that by kubectl, and then create ns, and let's name that namespace shop. Quite simple. Oh, that already existed. Okay, fair enough. As I told you, that cluster existed before, so I ran a test before I actually run that demo with you. So that namespace is already there. That's fine. It's certainly not there on the AWS cluster, the AWS TKG cluster. It is not. So we run the create ns shop here, and just to verify, this is our namespace. So we now have the 2 namespaces in place, but the step that's missing is to connect the 2 via the global namespace in Tanzu Service Mesh. And to do that, we go to TSM, we go to the GNS overview tab, and that gives us the option to create a new global namespace. So let's call that shop. As simple as that. GNS for the shop application, just to be a bit descriptive. So here's the thing. When we want to use global namespaces, that global namespace gives us a domain. And when we try to resolve services in that domain, that will be in the global namespace. So we need to tell our application, instead of resolving a service, for example, database dot something, and then shop.local, just for instance, because that shop.local would be the domain in the local namespace. We need the application to try and resolve shop.global if we say shop.global is that domain we want to use in the global namespace. Okay, so at the end of the day, the whole magic behind global namespaces lies in a combination of DNS tricks in combination with tunneling traffic in an encrypted way to the other cluster. All right. Right. So we choose shop.global as the domain for our global namespace and hit next. In the service mapping step, what we need to do is tell Tanzu Service Mesh which namespaces on the Kubernetes clusters are part of that global namespace. So in the first mapping, we say, on the remote shop cluster, please add the shop namespace to the GNS. And then we add a second mapping saying, on the on-prem shop cluster, please add the shop namespace to the GNS, right? Because we have 2 shop namespaces on our 2 individual clusters. So the rest of the steps is nothing that we currently need. As I said, there are more features to Tanzu Service Mesh than what we're going to be using for this demonstration. So don't worry about that. We'll just hit next and finish. And that creates our global namespace in the background and sets everything up so that cross-cluster communication can actually happen. Good, so clicking into that global namespace, we are in the GNS topology tab here now, and that means as we deploy our application, Tanzu Service Mesh is going to draw a topology for us that shows us which service communicates with which other service and how often and what is the error rate on those calls, etc., etc. But TSM and service meshes in general, they need to learn that by observing traffic, right? So that means later on we will have to wait a bit before the service mesh will actually show us the right topology. So let's start and deploy things. We go to the Vsphere Kubernetes cluster, and I prepared the manifests already, which we want to deploy. Basically, I have, we need some preparations like secrets and Istio gateways and things like that. And then we have the application and the catalog. So the catalog service is what we want to scale out, right? And the application YAML contains the rest of the application. And then we have a load generator, and that load generator is important to generate traffic so that service mesh can actually show us the right topology. So I wrapped all of that in this little script. So we're basically just running kubectl -n shop apply this YAML file in that namespace, this YAML file in the same namespace, and so on and so on. The order doesn't really matter. Kubernetes is not too picky about that. Okay, this is done. Let's have a look if everything worked as expected. So we're checking the pods now, and it looks like they are coming up successfully. Each of these pods, by the way, gets its own sidecar proxy, just because this namespace is part of the service mesh. That configuration doesn't have to be done in our YAML files because Istio is going to auto-inject that for us. And that's the reason why we have 2s here instead of 1s, right? Because that means 2 containers are supposed to be in that pod, and the first 2 means 2 of them are ready. So all the pods, all the containers are ready, everything is running, and the application should be ready to receive workloads, right? Let's have a look at Tanzu Service Mesh. It auto refreshes every once in a while. And here we have some first information about traffic Tanzu Service Mesh has seen. And we might just need to wait a few more seconds for the second refresh before the actual topology map should be laid out for us. So we can now see a nice topology map of the shopping application that we're working with. We got the shopping service in the front, the catalog service, the user service, the order service, the cart service, some backends behind those. And in this case, there's even a payment service sitting behind the order service. So lots of cascading calls when people start making requests. So what we want to do now is, as I said, let's quickly repeat the scenario, right? Because that's already a while ago. So marketing has planned a campaign starting next week, and we expect that the catalog service, especially, but also all the other services, they will see a significant increase in load, while the others are expected to rise a bit. The catalog service is expected to rocket, right? And the local data center, so therefore the on-prem shop cluster, that is completely exhausted, right? We are at our capacity limit here. We can't scale up or out or anything anymore. It just doesn't work. There's nothing we can do. So we want to move this catalog service and its database to a cluster in the public cloud, so we can give all the other services some headroom to scale, and we get a significantly higher scaling limit for our catalog service, right? That's the idea. So to do that, we go ahead and deploy the catalog service into the AWS-based TKG cluster now. So I'm switching over to my AWS tab here. Let me see. All right. I forgot to clone the repository. That's okay. Cool. So we have the same set of deployment manifests here. And again, I prepared a little script to deploy these things. We only want to make a few changes here. And that is, we want to tell the namespace so everything gets deployed into the right namespace. So we're preparing, we're making some preparations, the Istio gateway configurations, the secret that the catalog service needs, and then the catalog service itself, right? That's all. So we now just run that script. And assuming that we're still connected to the right cluster, let me double check that. If we list the pods, we see catalog and we see the catalog database. Both are being initialized, and it shouldn't take much longer for those to actually be ready. So both pods are running. Let's switch back to Service Mesh to see what has changed. So obviously nothing in the on-prem shop cluster has changed. We see there's something in the unconnected services, right? So it has discovered the services on the remote shop cluster, but it doesn't know much about communication paths yet. So let's wait another cycle. And here we go. So the topology map now includes our remote shop cluster. It has discovered the catalog service talks to the catalog Mongo service. And what we want to do now is basically take away the catalog service that is on the on-prem cluster from the shopping service, so that the shopping service will rely on the catalog service in the remote cluster instead. So that should be quite simple. We just go to our Vsphere environment. And again, I just prepared a quick script for us to make that easier. So we're basically just running kubectl-n shop delete -f catalog YAML, and that deletes all the resources defined in that catalog YAML we applied before. So let me execute that script, and it should be gone. First pod's gone, and the second one is gone as well. We get a refresh in 1 second anyway, so let's just wait for that. And we can see it has vanished from the topology map in the on-prem shop. So there's no catalog service here anymore. It has discovered that successfully. But we're also not seeing an arrow going from the shopping service over to the catalog service, because that's what we would expect now, right? And as I said, service meshes learn about topologies by observing traffic. So we just need to wait until enough information has been gathered so it can actually tell. All right, so that's an interesting change in the topology. Lots of arrows have gone, and that's because it hasn't observed any traffic for long enough to remove those arrows. Now, if I switch the data I'm looking at to the past 30 minutes, I'm getting that data, that information back, right? And therefore a better topology map. So let's give it some more time. We should start seeing traffic going from the shopping service to the catalog service over here in just a few seconds. And here we go. Just as predicted, we're now seeing communication going across clusters from the shopping service in the on-prem shop cluster, across the internet, to the cluster running on AWS, and to the catalog service that's running there. Okay. And now we can, of course, just go ahead and actually scale, right? So kubectl, now that we have enough space available, we can have a look at our deployments, and we can say, let me scale that deployment called catalog, and let's set the replica size to 10. And we have scaled up. We're now scaled up to 10 instances, which was not possible in our local data center anymore because there were no resources. And of course, we're not seeing a change in the topology map because the topology map works with services, not with pods, right? That concludes my demonstration on multi-cloud with Tanzu. I hope all your questions have been answered in the chat. If not, I'm going to be here for a while. Keep posting questions and I'll try my best to answer what is left.